Math and Beats, welcome back. More videos on logic and proofs. Now that we've gotten a bunch of techniques of proofs and some vocabulary out of the way, we are going to, in this video, show an example of how you can prove what's called an existential implication. So let's take a look. Here's the example. Proving an existential implication. What is that? Here's what we want to prove. This statement right here. All right, what does it say? For every, remember that little symbol is epsilon. For every epsilon that's bigger than 0, there exists some other number, delta, such that this statement right here, x is between 2 minus delta and 2 plus delta. If we have that, then it implies that this statement here is also true. And that is 10 minus epsilon less than 4x plus 2 less than 10 plus epsilon. So you kind of figure what we're trying to do here and why it's called an existential implication is because we're saying that for every epsilon bigger than 0, there exists, right? Existential. There exists some other variable, delta bigger than 0, so that this statement right there implies this other statement right there. Hence, we have existential implication we're trying to prove. Okay, so how are we going to do this? Well, first let's take a look at this paragraph I put down right here. And that is, we're trying to prove that something is true for every positive number epsilon. Right? I mean, that's what we're given. For every epsilon bigger than 0, we're trying to prove something else. So the goal really is to find some other number, some positive other number we're going to call delta, given that we have a positive number, epsilon, and it has the property of the implication. That is, x is between 2 minus delta and 2 plus delta, and that implies that 4x plus 2 is between 10 minus epsilon and 10 plus epsilon. So we're just trying to rephrase it, restate it. What are we trying to do? That's always a good thing to start with when you're doing a proof, is that, okay, we're trying to prove something, but do we even understand what we're trying to prove? Hopefully we have a little bit of understanding now. Now, in symbols, using quantifiers and whatnot, we could rewrite this statement. So remember the statement right up there, that whole statement. For every epsilon bigger than 0, there exists a delta bigger than 0. Remember these symbols, such that 2 minus delta less than x less than 2 plus delta implies that 10 minus epsilon less than 4x plus 2 less than 10 plus epsilon. So it does look a lot more fancy, and we like to write out the symbols because when we actually go write the proof, as we're going to do in a bit, it's just cleaner. But, you know, you could use words if you really wanted. Okay. Now, strategy here. Before we actually write down a proof, a strategy would be, hopefully we can find some relationship between delta and epsilon, which always makes the statement we're looking for to be true. If we could do that, then we could write the relationship between delta and epsilon and show that it's always true. Okay, So what is this relationship? First of all, we're going to start with this right here. The right-hand side of the implication we're trying to prove. If we solve that for x, -2, everywhere in the inequality, we get the next statement, 8 minus epsilon, less than 4x, less than 8 plus epsilon. Then divide everything by 4. Just basically solving this compound inequality for x. We get the result 2 minus epsilon over 4 is less than x is less than 2 plus epsilon over 4. So that's great. We're isolating the x because it tells us we should let delta be epsilon over 4. Why is that? Well, because go back to the beginning here. Remember what we're starting with, the implication. That statement right there, right? 2 minus delta less than x less than 2 plus delta. And we just found down here that if the right side of the implication we're trying to prove must be true given that, then this circle down here, that has to be true. Now look at the two statements. You see? They're equivalent in a sense that if we let delta be epsilon over 4, then the statement that we're looking at down here at the bottom is literally equivalent to 2 minus delta less than x less than 2 plus delta. So this is a strategy that can be done when proving an existential implication. That is, what are you trying to prove? And whatever two variables are involved, try to find a relationship between the two such that the implication is indeed true. Now, if you can't find a relationship between the two, either something went wrong with the math, or it's possible that the statement is not a statement that is true. But because we are actually directed in this example to prove the statement, we know there's got to be a relationship because we know it can be proven by the directions of the example. All right. Now, that's not the proof. That is just kind of side work so that we can then go and construct the proof. A proof should always be beautiful, organized, and in a nice logical deductive order, if that's the technique we're using, which we are here. So here is the proof. Now that we found a relationship between epsilon and delta, here's what we're going to do. We're going to let epsilon be bigger than 0 because that's what we're assuming to be true. And on top of it, let's now let delta be equal to epsilon over 4 based on the results we found just a moment ago. First thing to notice, delta must also always be positive as well, bigger than 0, because if delta is bigger than 0, then any positive number divided by 4 is still also positive. Now we go for the relationship of the implication we're trying to show, and that is, okay, now, whenever we have this statement, we want to show the implication that we're after. We have, well, since we're letting delta be equal to epsilon over 4, that statement is exactly equivalent to this statement here, just rewritten with the epsilons. And now we're going to go ahead and rearrange this. So in the next step that got me here, I just multiplied all the parts of the compound inequality by 4. So everything get multiplied by 4. 4 times 2 is 8. 4 times epsilon over 4 is just epsilon. And 4 times x is 4x. And then finally, this last step from here to here, all I did, add 2 everywhere. Add 2, add 2, add 2. And then you get this statement. Hey, guess what? If we start with 2 minus delta less than x less than 2 plus delta, it's always true that if we just let delta be epsilon over 4, then 10 minus epsilon is less than 4x plus 2 is less than 10 plus epsilon. So the implication has just been shown to be true, and hence we have shown for every epsilon bigger than 0, there exists a delta bigger than 0, right? We found one. What was it? It happened to be epsilon over 4. So there exists this delta that's positive, so that 2 minus delta less than x less than 2 plus delta implies that it must also be true that 10 minus epsilon is less than 4x plus 2 is less than 10 plus epsilon. So there is an example of proving an existential implication. It is of relevance because at some point soon, we're actually going to go and look at proving what we call limits. And in order to do this, we often have to prove existential implications. So there's the video. In the next video, I'll show you another example of a proof, but it'll be a different type of proof, not an existential implication. All right, that's it. Time for a short beat until the next video. Math and beats. Boom.